This is the experimental setup for fuse characteristics. Okay, so this is the supply unit. Okay, so from this supply unit, this is the switch, okay, which is initially turned off. Okay, supply voltage we can see it is 0. So actually in this board we have 3-phase connection. Okay, so 3 phases R, Y, B, and this one is neutral. Okay, but we need only single phase supply. Okay, so since we need only single phase supply, we are taking only one phase and one neutral to do this experiment. Okay, so one person remove this board, keep this, remove this, okay, keep it aside. Okay. So here we can see simply some connection knobs are there which have been fixed here. Okay, so this is a fusing wire, and the current carrying capacity of this fusing wire is only 5 amperes. So it's a very thin wire, isn't it? It's a very thin wire. Okay, its current carrying capacity is only 5 amperes. So here we are going to study the characteristics of this fusing wire, and we will see the main purpose of this. What is the fusing wire property? It has to protect the equipment or the device ratings of the equipment. Then that current will initially flow through this fusing wire. Okay, and this fuse will blow out, so that it will disconnect the supply from the equipment which has to be protected. Okay, so here in this board, this there are few knobs which are here, and there is one common knob here. So there is a specific distance from this common knob with respect to the other knobs. So initially the distance between this knob and this knob is 5 centimeter. Okay, this distance between these two knobs is 5 centimeter. So if I am taking a fusing element, okay, if I am connecting it across these two knobs, okay, so that means that the length of the fusing element is 5 centimeter. That's all. Okay, so if I want to increase the length of the fusing element, and if I want the length of the fusing element to be 5.5 centimeter, then I will connect between these two knobs. If I want 6 centimeter, I will increase the length of the fusing element, I will connect between these two, and so on. Okay, so these knobs are connected in such a way that if we want, we can increase the length of the fusing element. Okay, and the distance is fixed here. Okay, now, so in order to do this experiment, we need a fusing wire, and we need some 2 terminals across which we can connect this fusing element. Okay, and we need a dimmer stat. Okay, so the dimmer stat range is 230 volts by 0 to 270 volts. It's a single phase variac. Okay, initially before starting the experiment, we must make sure that the dimmer stat is in initial 0 output position. Okay, and we have considered a resistive load here. This is the resistive load, and for this experiment, one person just take this red wire. So this is the phase. From phase, we have to give connection to the input phase terminal of the dimmer stat. Okay, and from the neutral, we must give connection to the input neutral terminal. Now input connections for the dimmer stat are over, supply is given to the dimmer stat. Okay, so from the output, output phase terminal of the dimmer stat, we must give connection to the common of the ammeter, and from terminal number 10. Okay, so of this ammeter, we must give it to this fusing box. Okay, you can call it as a fusing box, and from the other terminal of this fusing box, we must give it to the load. Okay, so from load, okay, so load phase we have given. From the neutral terminal of the load, we must give it to the neutral terminal of the output of your dimmer stat. So connections are very, very simple to do this experiment. Okay, so initially this is the single pole single throw switch. So initially we will keep it closed since we are doing the experiment. So when supply is turned on, we don't want the current to flow through this fusing wire immediately when supply is given. Why? Because we want to note down how much time this fusing wire will take to blow out. Okay, for that reason we won't we are initially keeping this single pole single throw switch closed. Okay, as soon as we want to know the time taken by this fusing element, we immediately what we will do is we will open this switch. Okay, if anybody has any stopwatch in the mobile, stopwatch. So now we will connect this fusing element across these two terminals. Okay, so just connect it. Supply is off, so we need not worry about anything else. Okay, and we must give the connection in such a way that the wire should not be too tight between these two terminals. It should not be too loose or too tight. Yeah, it should. You just check. Yeah, that's all. Now you just move it. You try. If it is moving, that means that it is okay. It's okay. Okay. Now we have connected the fusing element here across these two terminals. Now we will keep this box over it. Why? When the fuse blow away, we don't want the sparks to come in beyond 5 centimeter. Beyond 5 amperes, because our fusing element current carrying capability is 5 amperes. So we will allow more than 5 amperes current to flow through the fusing element. So for different values of fault currents, we will note down the time here in this table. So initially let us turn on the supply with two hands. Okay, we are using only one hand. Okay, so we have given the supply. Now press this green button. Okay, so it is approximately more 400 volts. Okay, so since it's a three-phase supply actually, but we are taking only single phase. Okay, so now we will vary the thermostat till the required current flows through this. The required current is shown in this ammeter. Okay, so the current is actually flowing through the load. Okay, so just vary the thermostat, and while varying the thermostat, look into this meter. Okay, so 5.2 amperes. Okay, it is 5.4. Okay, now okay, it has taken show me 3 seconds. So now for 5.4 amperes of current, the time taken is 3 seconds. Okay, so for 5.4 amperes of current, the time taken is 3.23 seconds. Okay, now we will increase the current to 5. Okay, fuse has blown, so minimize it for next reading. So we will turn off the supply. Now we have to we have to replace it with the new one. We have to take at least 3 readings so that we can plot the graph. We need at least 3 points to plot the graph. You open it fully, that switch. If you open it fully, you will be able to easily push it inside.
one.
Yeah, no, first one only.
one.
For the first one only.
Okay.
No, okay. Okay. Now turn on the supply. Okay, vary the thermostat till ammeter shows 5.6 amperes. Yeah, 6 amperes, and the stopwatch is initially at 0. So open the switch. Yeah. Yeah, it has good. So 2.66. Okay. So minimize the thermostat. Now turn off the supply. Okay. Now replace that fusing element. Okay. Okay. Now turn on the supply. Turn it on. Now 5.8.